Swayam Prabha. Digital India. Educated India.
Welcome friends, I am Arul Jayachandran. I am a faculty at a Department of Civil Engineering, IIT Madras. I will be talking about how the steel construction is going to dot our skylines possibly in the next decade, and the lecture will be titled as Steel Construction, a Promise for the Future. In fact, if you see the growth of steel consumption in India, you can't say it as an amazing journey, but we all started a concerted effort in the year 1999, and a decade later the usage of steel has doubled. The reason is there is a metric in economy which says the growth of a country is directly related to the consumption of steel. This means the infrastructure is growing, the housing infrastructure is growing, so possibly more steel is being consumed. So the government of India wants another about 20 million tons of steel to be used in another but few years. So this says that the usage of steel in construction, not on the traditional avenues, definitely has a bearing on in the Indian economy. Now these are the areas of potential large growth of steel construction in India particularly. I am not talking about the traditional avenues like industrial structures, you have trusses, very many small amount of steel construction, but it is amazingly new type of structures. The one is the housing, the second is the medium to large span bridges, because the requirement of these bridges is not by the strength or the load, but it is going to be entirely a community dictated design parameters. I will tell you what are they as the lecture goes on. Secondly, we talk about all these FDI, the foreign direct investment in India, which is going to create quite a number of marketplaces which are for the short duration. So possibly steel is a very good option, and the number is going to increase quite amazingly. And the last point is, today we are talking about sustainability, and every citizen is very sensitized about environmental awareness. So steel is good for a society which is environmentally sensitized. Right. Now I did not say that impediments, but I say perceived impediments to the growth of steel construction in India. Possibly we can overcome that very easily. The first one is steel construction involves very many players. We say the steel chain. We have a producer, we have a fabricator, we have a contractor, who have a designer. The chain is very long, and there has to be some institution which unites all these stakeholders in this business. Unfortunately, we do have organizations set up by Government of India. It is doing its best, but all the private players should come together to make it more meaningful. Today it is only piecemeal and fractured. Now the culture of alliance, like every company wants to make their product, but none of them come together like they make an alliance, and so that the steel can go into complementing areas of construction, which is unfortunately missing in Indian context. Okay, this is not only for steel construction, but also for techno-legal issues. If the stakeholders or the players come together, all these issues which are against the steel construction can be dealt in a much better way. And finally, we have to admit that the weakest link for the steel construction in India is in the fabrication, because we do not have a medium grade fabricators. Either we have the top notch fabricators or we have the roadside fabricators. Possibly this is one of the the avenues that India has to grow. Right. Now the impediments is not a problem for us, because we have success stories. We started constructing the pre-engineered buildings called the PEBs in the year 1999, and today it grows around 20 to 25%. and it has almost nudged out the traditional structural steel work. You find every industrial structure is going to be the pre-engineered building, but when the PEB was introduced, the market or the contractors were not very receptive. They had quite a lot of questions, and today PEB is unstoppable. So possibly because it offers a total solution, and this has been conceived as a big advantage by the contractors. So I am sure in future the steel construction is going to grow in a big way in a country like India. Well, I will now give what are the avenues of large usage of steel construction. This is precisely what I said earlier. This is not about the steel which is going to go into a traditional avenues which have already been used. This is completely new avenues. The first one is I take about the residential construction. During the end of my lecture, I will show a live example of residential construction that is currently happening in Chhattisgarh, and this one is I was fortunate to go and document a residential flat, about 180 flats. Why all these quick time constructions, or we say rapid constructions coming up? Because in India also we have started feeling that the time is money. We all know that the Western world runs on the principle time and money or one and the same, right. I would like to give an example. This is a 180 flat multi-story building that has come up in 10th Street of Atlanta, very near to Georgia Tech, and the specification for the construction is not the strength nor the material, but the time. They said within 9 months the entire construction is to be completed and has to house around 180 students. So the time was the major parameter for this, right. Now all these flats are steel concrete composites. You can see this. Much of the steel is appended to the existing facade. You can see here we have a sunshade which is appended to the brick facade. You can see this, all these sunshades or any other appendages can be fabricated outside, can be quickly fixed onto that. So you can see this, this is not a brick facade, but just it is a CP board, and then externally we have pasted small amount of bricks, giving us a beautiful view of a traditional brick building. What I said again, steel staircases are used. You can see there is a layer which is called a resilient layer so that the noise of the steel staircase does not come into account, but many of these structures can be fabricated and they can be shifted to the site, and the construction can be made very quickly. Right. So this is the external view of the 10th and home. As I told you, is about 180 flats are there, but does not look like a steel concrete composite building or even cold form steel building. It presents a beautiful view which merge with the existing other structures. It is not like transplanting something else, but you can see this. So the residential construction steel is be used. This growth is going to be much higher in India in future, right. Now this is not the residential sector alone. The commercial buildings, as we all know, like its time is the major criteria for the commercial buildings. So I was fortunate to document one of the commercial building which is called the Turner Broadcasting in Atlanta. Again the specification for this is 6 months, because this is purely a competition between two different players, and then say a particular company comes and tells the contractor, by this time I want my structure to be ready and be operational so that I gain into the market. So this was a very good case for me to present. You can see here, this I am just taken the photograph in the 3rd floor. That means the next day was the concreting, right. So you can see in the 3rd floor, you can see the steel main beams. You got the secondaries on which we are putting a steel deck sheet which has got corrugations to give us the moment of inertia. So we will have to put a small amount of reinforcement and then concrete them on the top. Now that gives an advantage that you can see here the 2nd floor is ready for work. In fact, when I was there, the 2nd floor was occupied by the service crew. they start putting the pipes, they can start putting the vents. In the first floor, as I will see the next slide, the services are nearly completed. So, what we can see is the construction sequence, not necessarily wait for the entire frames to be ready or the walls to be ready. In fact, by floor and floor, when the last floor is finished, I think the ground floor can be made ready for occupancy, right. You can see here one of the disadvantages, I said, the fabrication. The great advantage of the steel construction is much of this material, I mean the components are fabricated elsewhere, so it does not block the site, it is brought and then they are bolted at site very quickly by using pneumatic tools. But probably India has to grow in this particular area. You can see here the man is working, he is a service crew member. That means while the concrete is going to be there, the civil crew there at the third floor and the second floor is occupied by this the service crew. Right. Now, this is the photo of the first floor. You can see here these are all called wall studs, right. These wall studs are going to receive your cement particle boards or gypsum boards. So, they almost are ready. You can see here the inside of all the wall studs are ready, and then the occupancy, all the services can be started. Now, this is also a lightweight roof, which is the same building, which is built in about 2.5 days. Okay, once the spans are ready, all the components are fabricated, then fitted and bolted in the site. So, the entire construction was finished about 5.5 months. Good. So, I would like to go another avenue for steel is called the public structures. Many of us think that the public structures are being not used, but they are being abused. So, steel is not a preferred material for public structures. Quite I found many of the public structures in the western world or even some part of Delhi amazingly performing. So, this I will just give you a few examples of how the steel has been used in public structures. This is the Hartsfield airport. You can see here all these RC beams, and on the top of the RC beam they have synthesized a steel space roof. Okay, this is the steel space frame or a space roof, which is actually architecturally synthesized. You can see on top of it a steel sheeting, and amazingly it has been integrated or synthesized with existing concrete structure. So, we can see steel can be a complementary material in very many situations, especially for beauty, for aesthetics, and also the time of construction. So, this space structures, which I will cover a little later, and you can see here today we talk about sustainability. This was a actually a underground station, Midtown Atlanta. So, there are simple truss structures have been put with the light, the natural light is to come in almost entire daytime. You do not need any light. You can see here the lights have been switched off, and you are getting quite an with an ample amount of light inside the station. So, what I am saying, this steel can merge with say material like glass or any other material, which is going to give you an advantage in service also. So, this is one of the public structure in which glass and orthogonal truss system is used for in a public place, right. Oh, this is beauty. Actually, you can see here this all the columns used here are steel concrete infilled columns. You can see here the service, some of the water drain, we call as the drain into the pipe has been taken in. This is a public structure and very nicely integrated with the lighting. You can see the buses, and you can see here this is the another view of the public station. You can see lot amount of floor space is available for them, because the intercolumn space is quite large, and the size of the column, since we are putting a steel outer shell and we are infilling with high set concrete, the column can be quite slender, and then we for the same area we get more usable floor area. So, this is the circular columns are not only for visual appeal, but also for give us a good sense of beauty on that. So, it is not a real concern that steel can't be used in public structures. Now, The next is for architectural splendor. Right, this is the Walmart Lithonia. You can see here there is a large column free space. In fact, if you see the next slide, you see almost it is like a unsupported free space, because you can see these columns are very slender. They do not even come into your eye line at all. So, you can see here the marketplaces are going to increase. That is the point I was making. Today India, we are moving towards merging, and globalization is taking place in a big way. Quite a number of marketplaces go, not only for the consumer goods, but even for storage of production materials. All right. So, in that avenues, actually steel can give you a very good advantage, right. So, this is also a beautiful architecture. You can see here light and trusses have been merged. It gives a fantastic view. You got a very large space in which you never knew like such a structure, I mean steel structure has been put in. So, it merges, you can see the sheeting or the top, it is steel, and all these simple trusses, you can see the fly braces. So, very small elements are put together into a quite rigid system, which offers us a very good advantage for steel for architectural beauty, right. So, this is an Walmart Lithonia store, right. Also, in the case of the Fernbank Museum, we are going to have some very monumental structures maybe in the future. Now, we see monuments are being built for very popular political leaders, or for remembering a particular event. So, in all of them steel provides a very good. This is the atrium of the Fernbank Museum of Natural History, again in Georgia. So, you can see here glass and the traditional steel truss work have been combined to give a beautiful view. Not only that, you can see here steel has been appended to the existing masonry structure as well. So, this particular material is not a standalone for use, but it is going to merge with masonry and quite nicely with concrete. And the usage of the steel, say for example, there is a large party hall. So, you have a column free space taken only by one particular central octagonal column. So, this column supports a big truss work, and the truss work on top of it we put glass. So, even at the evening, sometimes they got moonlight dinner here, no lighting at all, it is just purely by the moonlight thing, the dinner is being conducted. So, the point which I am making is steel can be appended or complement any architectural space that you are doing. So, you can merge with the masonry, you can merge with concrete. At the same time, this can also be used to take care of load. You can see here the truss reaction is transferred to the masonry wall by an appendage. So, this kind of integration provides steel very good for an architectural purpose. Like this is initially, when I went and saw the CNN Center, I thought it was a staircase, or it is just for landscaping. They have introduced a large space. The architects introduced this just to break the monotony, to give a feeling of that. This is just actually an entity that is only provided for internal scaping. So, it was another innovative use of steel that I have seen. Even architects use a fair use of steel in the construction, both for architectural splendor also. Now, I move on to some of the real world space structures, because as I told you, the marketplaces are going to come up in a big way. So, we are going to have quite a lot of space structures, and of course, everybody knows the most popular nest, the Beijing Olympics, which created many things can be done with steel, not necessarily in a very prismatic and nice way, but we can do shapes which can represent nature also, like the nest. The next one is this double layered space construction is quite popular. You might have seen this as many petroleum outlets, but in near this Hyderabad or the Hyderabad area, you can see large amount of these space structures. What is the advantage? All these components are very slender, and you can cover a large unsupported space. You can see here the column. The column is a very slender column with a tripod, over which you have got an arched two layer truss is there. So, these can be actually dismantle and you can use it elsewhere. So, the one of the major advantages for this is in the future there is going to be lots of marketing space. Steel can be an ideal material for quick erection and has to be shifted somewhere, it can be very easily shifted. So, the double layered grid, it is a very good system to span temporary, but of course large spaces. Now, this is one of the pyramid structures. You can see here the space structures have been used for architectural beauty also. See, one particular reason for all these space structures is you do not need a big skilled labor to construct it. Once you have got all the Mach number of all these space structures, which will tell you like, okay, the member is going to the north or the south or the east, and then every member is numbered. Okay, every node will be numbered. So, the connection between numbers is just by simple people. So, we can get untrained labor also to construct all these space frame structures. So, the next part is bridges. Quite unfortunately, bridge was the primary construction material for the bridge structures in the British times and even during our independent periods also. But unfortunately, the high deep sections were not available and the fabrication was not supporting the growth of the steel bridges. So, possibly there was a drift between steel to pre-stressed concrete and other structures. Now, this is what the point which I made. Now, the bridge structures, let us say in urban like in metropolitan cities or tier 2 cities, it is going to come not by the strength and the traffic, but by the constraints the space is going to offer. So, this is one of the curved box bridge. Imagine in Chennai or in Mumbai, we are going to have a bridge. You can't locate the bridge piers as freely as we think, and it's going to be determined on the space available or the kind of structures available. So, very many constraints are going to come. So, if you want to build a quickly a bridge, a curved bridge or a box girder bridge, steel is wonderful option for that. I can show you these are the composite decks, right. You might have seen this today. The NHAI proposes many of these steel concrete composite bridges to span over the railway bridges. What is the reason? Because I can easily launch, there is no blockage of traffic either train or road. So, the columns are erected, over the columns we go and insert our beams, and you can see here these beams will have what is called shear connectors, and these are all braces. As you know, like every traffic goes, there is a lateral movement is come. Also, we would like to introduce these braces for the best performance of these bridges. So, this is quite popular now in India. Most of the bridges which spans between roads or the rails, railway tracks, are coming by this composite technology. So, that is a big advantage for us because we can just put on the concrete deck very easily. The concrete is very good, we put reinforcements and it can be cast without blocking anything at the bottom. So, these kind of the space constrained bridges are becoming quite popular in India as well. Of course, the suspension bridge with the cables, you can see here you have the cables, you have the suspenders and deck. This is a classic example. We have a couple of bridges in Goa which are cable suspended bridges, but only thing, as the technology and the competence of the engineers or the contractors start increasing by doing couple of bridges, I think more number of bridges will be there. This is especially for crossing the waterways. We have a problem of the space is being covered, we have a navigational space. So, all this can be covered. So, this is a good example of where steel can be used, and again this is an example. You can see here we have a deck bridge which is immediately converted into a through bridge. This is because of the navigational depth which is required. So, many times the structures are built not for the strength or the amount of load that comes. It is not about how many broad gauge trains are going to come, but it is the navigational, because we are going to they obstruct the navigational way, possibly the fishermen or the fish species to migrate. So all the structures are going to translocated into a very serene environment. So most of the time the structural systems are determined mostly by the environmental conditions. So you can see here a clear example of a large navigational way height is required. So a bridge from a deck to has been converted into a through bridge. So such kind of special usage can be there, and this is called a transportable Bailey bridge, right. Many times we use this, the army used it in their operations. This kind of Bailey bridges are quite popularly used in the northeast of our country, where deep ravines and small spaces to be crossed, you can use this modular bridges. These bridges are transported, they are fitted inside, and the deck is paved and you can cross with that. Some of you may remember that when the arch bridge in the Jawaharlal Nehru Stadium before the Commonwealth Games failed, within about a week the army people came and put the Bailey bridge for the pedestrians to go. Another one is the point which I say, this is really amazing bridge that I have read about. This is in 2012. This bridge was built in Japan, and the reason is beauty. You can see here, this is backwater, and you can see an estuary over here. This is the land for lots of birds and fish species also, and the egret is one of that. It's like a just like a crane. Now the construction constraint came because the vertical pylons were obstructing the navigational way of these birds, the egret birds. So what happened, what they did was, from the traditional bridge they have just lowered the supports. You can see here, this was the normal cable stayed bridge that we use it. So this support for this span alone was taken down. You can see here, this is the space in which the egrets fly. So in this area the system was lowered so that the pylons do not obstruct the space of the egrets, and this is the real bridge. You can see the support at the bottom, and it is not for the entire stretch but only in the stretch for estuary. So when these kind of environmental constraints are going to come quite often, naturally in India also is going to come, I think steel is an amazing material where you can really customize the use. This was a bridge, you can read it in the website of Japanese Institute of Steel Construction. Is a fabulous structure, how the entire mechanics team, the environmentalists, all of them sat together to provide an unobstructed space in the estuary. So this is they call the cable egret bridge in Japan. So my point is that the requirements of the structure, the structures are not necessarily going to be with respect to the structural parameters, but sometimes mostly the social parameters, the environmental parameters, in which steel can play a big role. Okay. Now the next part which I want to say is the steel concrete composite structures, in which we are getting the best of steel and concrete. I was amazed when I was moving in Chennai towards the East Coast Road. I found couple of steel concrete composite buildings have been completed not by engineers but by non-engineer. It was a non-engineered construction. When I approached them, then it was done by a contractor who has just went abroad and saw a building and come back. So he said this option is going to work. So this is a steel concrete composite system. You can see here, this is the steel beam over which we put the deck sheets. This is also a steel sheet, say possibly of 1 mm thickness, 0.8 or 1.6, depending upon the span I want to cover. Then over the top of it I put a very nominal reinforcement just for shrinkage and temperature, and we put what's called shear studs. Okay, these shear studs are the elements which are going to integrate the concrete deck and the steel part. What is the advantage is, if once I have the steel beams ready, I can just put the sheets on top of it. On top of it we can drive the shear connectors and we can just concrete it. No support, no propping is needed and no formwork is needed. So this was the one I was talking about, what happened in the Georgia Tech commercial building. Right. Now this is actual composite, how it looked like. You can see here the Young's model, the modulus of the steel and concrete is different. So at the interface they will try to slide across, as also they would like to come out. So we have provided the deck in such a way the uplift or the separation between the steel and the concrete is done. So this is how exactly how the system would look like, right. We have also have concrete columns, in which we can have a steel column, and we have put concrete around for say a fire protection, or we can have a steel shell or tubular section, an RHS as SHS, and then we can infill concrete into it, or both. This is the best system, in which the performance we have said that if you can use either of these two, we get quite a good advantage in terms of strength, right. Now this is the system, actual system that is look like. You can see here, these are columns, these are the primary beams, these are the secondary beam directions. We have just put the sheeting and then we have put the studs. You can see here, this is the nominal reinforcement that we going use it. We can come and see here how the decks are placed, right. See this is the primary beam between the columns, we have the secondaries, just over the secondary beams we can put the sheeting. This sheeting can be made to any length, because the rolling is done on the site. We got a coil of large length, so we can load it quite nicely onto the secondary beams, and after this the studs are driven, and the studs, or you can see here the studs are driven on the secondary beam. After that it is ready for concreting. One of the advantages of this is the nesting, right. All the deck sheeting material can be easily nested. So it provides me a lesser computational, transportation cost, as well as also storing space is very less. So it is not only in the strength alone, but all in the construction practices, these steel concrete composite structures are going to give us a good advantage. This is already we have seen how the deck sheet is placed. You can see a very long deck sheet as a single piece, right. You have the primaries between the columns, you have the secondaries between two primary beams, on which you have put the deck sheeting. How are these long sheets are transported? You do not need to transport, you can just go, you can have a rolling mill at the site and it will roll it for any length you want. So that is the advantage of these deck sheets. No need for make the sheets and have to be transported. The cold form steel structure is one of the avenue, like in which IIT Madras has also a long tradition of research and design. So one of these project which I was personally involved, like to explain, and what we see here is called a rolling machine. Now the rolling machine is the one which makes all these structural sections. You can see here the steel comes as just like paper rolls that we see in toilets, this kind. All these steel rolls can be cut into desired width for us to make the sections. So once they are cut, they are fed into the rolling machine like that. So structural sections are come out. You can see here now, here a section, a channel is produced from this. The length of these sections depends on the length of the coil or the roll. Now this can be made into structural members and also the structural framing. Now once they are made in the shop, they are transported like this. So from factory to second, see we have got 12-meter log trucks, and we can load all these materials onto the truck to the site, and there we have a very light foundation. You can see here the foundation is just a simple spread, it is not very deep, no piling. This foundation was for a G+3, right. So it was a very simple foundation on which we are going to erect. This is the computer design model, a vertex model of a G+3 system, fully cold formed. All these members are made out of the rolling mill, the channels. Now this is the final the rendered model of the house. This is the house that we are going to build, a G+3 system, right. Now this is how the residential, the G+3 was built in Parsada and Raigad in the state of Chhattisgarh. Now this is how, this is the stage in which it is being constructed. You can see here the stages of construction. You have G, 1, 2, third floor is being constructed. The total time taken for the G+3 was less than a month, because all these the skeletal members are manufactured. These are called cassettes. You can see the side wall, the panel units, these are called wall cassettes, and what is put on the top is called the roof cassettes. So, the wall cassettes and the roof cassettes are transported, and you can see here the flooring is by CP boards. In fact, in this project what we did was a 20 mm at the bottom and 18 mm at the top, and in between we had a steel the roof cassette, and on top of it would put normal ordinary tiles that what we see in our buildings. Now, this is the finished work. You can see here this is the work that is completed, and this is just going to be complete. You can see here the vertical staircase is of hot rolled steel. So, you can see the hybrid structure, all these ones which are galvanized cold formed steel G+3, and this is a hot rolled steel staircase. Now, this is almost completely over. You can see all the side walls are by CP boards like cement particle board, which have painted to look like same color. Even the floor also, it was not a concrete deck floor as I explained earlier. The floor is a 20 mm at top, and then 18 mm at the top, a sandwich with a roof cassette. So, we tested it and we found it is quite adequate. You can see here another construction is going to start side by side, and this is how the construction sequence happening in this, right. So, you can see here we are going to extend one floor. We are going to extend one floor. What it is, again on the circumferential wall, this panel, the wall cassette is fixed, and so you can see you will support, these are all temporary props till the top construction. You can see here all the walls are ready in about a day or two, then we put the roof cassettes, and since the connections are very simple, you can see here the connection between we call as the track, with the bottom track to the vertical column we put a small shoe, this is called the iron shoe. We can just pin this up into it. So, this iron shoe will give you the moment rigidity at the joint. And how do you fix these tracks onto that? Straight away drive a pin on the, so this is called self drilling, self tapping screws. So, what happens, they have a thread, and if you just drive it from one side, there is no need for any nut on the other side. So, the connections are quite faster, and that is how I said this is really, when I experienced this, a room wall was constructed nearly in about 10 minutes time. So, quickly there is easily, because the amount of the weight on this system is going to be very less. Probably in future lots of spaces can be acquired, not necessarily we should have the space. Any existing building, if you can take a light load about say 2 kilopascal load can be there, and easily these cold formed steel systems can be appended. This is a connection I said. So, finally I would like to summarize my lecture. Although this is a dream, what I tried to give an idea was what is the future of our skyline is going to be in terms of steel construction. Now, the future era also, it is going to be a era of time compression, because every project is set against a particular time for which people have to complete, and within the time the business grows. So, in the time of time compression, the time is a big investment along with money. So, in such a scenario I find the steel construction using hot rolled, which I told earlier, and steel concrete composites, which always gets you the best of steel and the best of concrete, and the cold formed steel structures appears to be very promising. Of course, this is not my dream, but it is happening in India. Only thing, we are in a starting phase. When more students start learning this, and more institutions start doing research, and you will find the steel construction in India is to grow in a big way. Thank you.